we will be looking at the NERC CIP cybersecurity requirements, a deep dive into power grid protection and beyond. In this webinar, we'll be talking about the NERC CIP requirements, which are regulatory and enforceable for the power industry across the US and Canada, and a small portion of Mexico as well. We'll look at some of the key factors for determining applicability of requirements, how they're structured, and also how they compare to some other industry standards and best practices like the IEC 62443 standard. And then at the end, we'll take a step back and see what we can take away from the NERC CIP requirements and how they're structured, how they've been rolled out, and kind of see what broader lessons we can pull from there. And so everyone, to quickly introduce myself before we jump into today's topic, I'm Patrick O'Brien. I am the Assistant Director of Engineering at Exida. I've been at Exida for a little bit over 8 years now and have spent a majority of that time in cybersecurity, but I'm a chemical engineer by schooling. And so did start out a little bit more on the process safety side, everything from HAZOP and LOPA to safety instrumented function definition, requirement specification, verification calculations. And about 6 or so years ago, really started to make the transition into looking at cybersecurity and trying to understand if attackers can get to these critical devices and make changes, what sort of impacts that may have, and where can that introduce additional risk that we may miss if we only look at it from the safety perspective. And so as part of that involvement in cybersecurity, I've been fortunate to work as part of the Exida team for writing our cybersecurity book, implementing IEC 62443, a pragmatic approach, as well as leading the project to write the CCPS concept book, Managing Cybersecurity in the Process Industry. And so as part of that, I've really enjoyed the opportunity to do lots of different site assessments, risk assessments, and work with different asset owners around the globe and in different industries, including the power sector. And that kind of is the experience that we'll pull from in the webinar today. Talk about some practical applications and things that we've seen with NERC CIP and how it relates to other standards. Before getting into the details of the webinar, I'd just like to give a real brief background on Exida for those who aren't familiar with us. We are a customer-focused company who helps our customers achieve safe, secure, and reliable solutions in a number of different areas. And so we were originally founded in 2000 as a functional safety certification company. So working with early safety logic solvers and PLCs to certify them to IEC 61508. Also working with sensors, valves, actuators that all made up parts of that safety instrumented function. And then over time, we've seen the standards that we've been involved with grow. We also can provide certification to the machine safety industry, including ISO 13849 and IEC 62061. We're a notified body for the machinery directive, and we are also a accredited cybersecurity certification body for both IEC 62443 and ISA Secure. So we've got a lot of experience working with components and systems, both on the functional safety and cybersecurity aspects. Our next portion, our lifecycle services, is where we work directly with the asset owners to help them tackle their safety, alarm management, and cybersecurity related challenges. And again, this is our group where we do work directly with the sites, doing on-site assessments, doing risk assessments, and really understanding what specific challenges they are facing, and help them identify the best way to address those. And then lastly, we have our enterprise tools group, which is our software group responsible for developing the Excellentia software. And that does include specific modules to tackle each step of the life cycle, from the safety side of things, doing HAZOP, LOPA, SRS, SIL verification, to alarm rationalization, and to the cyber side, doing cybersecurity risk assessments. and really helping make sure that whenever you're doing those life cycle steps, that you have an efficient workflow and that you are able to capture all of the information that you need. And so through that, we really have the opportunity to work with different stakeholder groups, not just the site operators, but also their suppliers to really get a full perspective of what's happening in the industry. And so for today's webinar, we'll be focusing in a little bit more so on the asset owner or end user side of things and looking at two of the, let's say, common cybersecurity guidelines that we see here in the US. One being NERC CIP, so the regulatory requirements for the power industry, and starting by getting a better understanding of what the requirements are in that standard, how they're structured, and key requirements to be aware of. Then looking at its relationship to IEC 62443, what are the similarities, what are some key differences between the standards, and then lastly, we'll look at what lessons we can take away from NERC CIP and kind of general lessons learned that we can apply, not just in the power industry, but in industrial cybersecurity as a whole. And so without further ado, we'll start by taking a deeper look at the NERC CIP requirements. And so to start, like any good engineering standard, there are a lot of specific acronyms and terminology that we need to understand in order to read the requirements and really interpret them. And so I have just a couple of the key terms called out as you work through the specific parts of the NERC CIP standards. There will certainly be some more terms and acronyms that you find, but this is just a good starting point. And so the first term that we have to get familiar with is the bulk electric system, or BES. And this is really the scope of where the NERC CIP standards are applicable. There are some guidelines on the size of a generation facility that it has to meet to be considered part of the BES. Also some guidelines for voltages of the transmission system. So we'll break those down a little bit more on the next slide. Then in terms of groups to be aware of, so FERC, the Federal Energy Regulatory Commission, is the group with regulatory authority over the power sector in the US. And they've then delegated the definition of the standards and enforcement to the North American Electric Reliability Corporation, NERC, which is the first part of NERC CIP. And then the second part is our Critical Infrastructure Protection. So these are specific standards that have been developed to ensure the protection of critical infrastructure of the power sector in the US, Canada, and northern part of Mexico. And then our last two terms are general ones that might be a little bit more familiar to everyone, but operational technology and industrial automation control system. These are our terms for our again, industrial systems that are making control decisions, whether it's a generation site control room or a substation, thinking about our PLCs, our RTUs, and the Windows devices that are connected to them. And so if we take a look at the kind of a simple diagram to show parts of our power infrastructure, broadly speaking, we can break it up into thirds. So our first third is the generation, so the sites that are actually creating the power, whether it is coal-fired generators or renewable energy, right? Whatever it is that's providing that power source. And for any sites with a single connection above 20 megavolt amperes or 75 for an aggregate, that is going to fall within the scope of NERC CIP. Essentially, that is any industrial size power generation is going to easily hit that threshold if it is grid connected. The next portion, the transmission, is the high voltage power lines for efficient energy transfer from where the power stations are to where the users are. And any transmission lines that are above 100 kilovolts those are going to fall within the scope of the NERC CIP standard. Then when we get downstream of those transformers to smaller distribution lines that are either going directly to consumers or to maybe an industrial user, once they get below that high voltage threshold, they're no longer in the scope of the NERC CIP standard. So that helps us to just get a visual view of what's in scope of the requirements and what's not. In addition to breaking up the power sector between generation and transmission, NERC CIP goes into great detail to specify specific functional entities that play a role in the power sector. And so the first entity that gets called out is the balancing authority. This is the group that is responsible for managing the power grid in a regional area. Typically, it's a regional transmission organization or an independent system operator, so an RTO or ISO, and they are the one that ultimately has the decisions of what sites are operating and generating, providing power into the grid. They make decisions about, how much power is available, how much power is needed. If they see a mismatch, they're the one who's going to reach out to an operator and tell them to, turn on a peaker plant or look to, discharge an energy storage to kind of meet that gap. And so ultimately, they are the group that is making those decisions and balancing, power supply to power demand. And they will, be communicating with the generator operator, who is the person that's there making real-time operation decisions for any power generating units. They do distinguish between the operator and the owner. So operator, think real-time operation. Owner ultimately owns and maintains the asset for that generating facility, but may outsource operation of it. The interchange coordinator or authority is that group that transfers energy from one power grid to another. So if we have local grid A and we need to supply a certain amount of power to local grid B, there's a specific group that manages that interchange as we cross that boundary. The reliability coordinator has a little bit of a step back. They're seeing all of these things that are happening, and if they see that something is getting out of balance or there's a grid stability issue, they do have the ability to jump in and override those local operators if they see that a change needs to be made. And then our last two groups, similar to the generation side, is our transmission operator and owner. So the groups that's actually operating those transmission lines in real time, and then the owner of that asset who's responsible for ongoing maintenance of the facility. And so the reason that it is really important to break it down into these functional entities is the NERC CIP requirements are determined to be applicable or not based on the impact rating of a site. And the criteria for the impact rating are very specifically defined for each of these different functional entities. And the full criteria and the process for going through and doing the impact level assessment is in part 2 of the CIP standards. And it's all about identifying those critical cyber assets, what sites are critical, what systems for those sites are critical. And for anyone who falls under the NERC CIP standard, this is the place to start. So you have to understand what your impact level is. Another important thing to note for applicability is it's not only generation sites that are, let's say, grid connected 100% of the time. If you do have a power island for your chemical site or your industrial facility, that you can at times connect to the grid and supply power to the grid or sell power back. If you're above that threshold, then that site is going to, or that portion of your site is going to fall under NERC CIP, and you're going to need to comply with the appropriate NERC CIP requirements. So that is a common case we see where an organization may have a lot of exposure and experience with IEC 61511 or IEC 62443. But when they're building their new greenfield facility and looking to have that local source of power, it can introduce some additional cybersecurity considerations. And if you have a case like that, or you have a case where you're implementing a new energy storage site and you're trying to understand where your impact rating is going to fall, you can use the criteria in part 2 of the standards to do that. And so some examples of things that are going to fall into a high impact rating or a high criticality for the bulk electric system cyber side of things would be a control center for the reliability coordinator. So again, monitoring multiple generators and stepping in if there's an emergency. That central nervous system is very important for the grid. And when we say control center there, we don't necessarily mean like a control room for a site or for an individual generation station. It really is that central monitoring of multiple sites and ensuring that the grid is reliably providing enough power. Similarly, that control center for the balancing authority, where they have greater than 3,000 megawatts, is going to hit that high rating. Examples of things that would fall into the medium category would be a large generation facility that gets above 1,500 megawatts as its maximum nameplate rating, or something that is identified as critical for grid reliability by the reliability coordinator. And really that's a caveat where, let's say in a certain region, a large generation facility only is 1,000 megawatts, but it's the main source of power in that area. And if those 1,000 megawatts go down, there's nothing else that can hold that gap. The reliability coordinator may come and say, okay, for this region, for these conditions, you need to meet the medium criteria, meaning low is not adequate. So there is a specific process in which people can be identified that they need to meet the medium impact level. On the transmission side, this would be any facility operating above 500 kilovolts or something operating below 500 kilovolts, but with a significant number of connections. And they do have some criteria to determine that aggregated weight value for figuring out exactly where you fall as a transmission operator. Lastly, any facility that is capable of automatic load shedding of more than 300 megawatts also would fall under medium. There are some criteria as well if it is connected to a nuclear facility that automatically bumps up into the medium category. And so there are certainly more factors than just these 3 or so examples for each level. Then lastly, for low, this would be a smaller generation facility. So maybe it's only supplying 500 megawatts or 300 megawatts, and it is not identified as critical by that reliability coordinator. Could be a medium-sized transmission operator that's below the 500 kilovolts and doesn't have enough connections that they get above that aggregated weight value. Or it could be a system that's more used for restarting the system and responsible for black start operations. And what's interesting in the later versions of the standard is the black start capability used to automatically push systems up into the medium impact level. And what they saw was, as a result of that and the added effort to reach and maintain the medium impact level security controls, companies were actually opting out of providing that black start service, and they were seeing that the overall reliability of the grid was going down because they had fewer choices or fewer options when trying to bring the grid back online. And so in response to that, they ended up dropping black start capabilities down from medium to low to make sure that the regulation didn't have any unintended side effects and actually go against its objective of making the grid more reliable. So this is a good example of a little bit of the give and take, even in a regulatory case where if it's applicable to you, you as the organization have to comply or there are fines, there still is an opportunity for feedback, and it's important to make sure that the regulator and the industry do have open communications there. And why the difference between low versus medium versus high is so critical is the way that the NERC requirements are structured. There are many more requirements that will apply to medium compared to low, and then some more strict specific requirements in how they're implemented between high and medium. And so the NERC standards are broken up into a number of different parts. The first number you see here is the part of the standard, so it ranges from 2 to 15, noting that 15 is not yet enforceable. That is a future state that will go live in the somewhat near future, where network security monitoring will be required, but the other standards are currently enforceable. And then the second number you can see is the version of the standard that is currently enforceable. And so for part 2, it's up to version 5.1a. For part 9, as an example, it's up to part 6. So depending on how the industry changes, how the threat environment changes, they do look at updating those requirements within NERC CIP. And what you can see is there really is a huge difference between what's applicable to low and medium sites. For low sites, they have to go through the asset identification, because if you miss that step, you may be going around thinking you're low when you really are medium or high. They have some basic security management controls, minimum awareness training they have to complete. They have some minimum incident reporting and response planning that they have to do, but it's relatively light requirements. Once you get to medium, the threshold certainly is drastically increased. The number of security management controls that you need, the level of training is significantly steeper. There are more technical requirements around, do you have a good electronic security perimeter for the site? Do you have physical security controls in place? Do you have integrity and data confidentiality controls in place? So there's a lot more that comes into it. And then for the high sites, again, it's the same areas as medium impact sites, but there are additional specific requirements or levels of rigor that have to be met for a high versus a medium site. And so without going through each of the 13 or so different parts in detail, there are a couple of key requirements, key trends that we can pull out from NERC CIP and think about what it looks for as a piece of regulation. So in terms of technical security controls, there's a lot of focus on the security perimeter and making sure that for those those transmission sites, that they have good network segmentation, right? Boundary devices, firewalls that are extremely limiting access, that they understand what communications are coming into and going out of the site. There's a lot of time spent on remote access and exactly how remote access needs to be done to the sites if allowed. Things like the use of a jump server and having requirements for encrypted connections, change of protocols, different best practices to make sure that remote access is secured. They also have a lot of considerations for the specific use case of the power industry. So specific requirements about how communications between different control centers need to be handled, and how you respond or have mitigations in place if those real-time communications drop. Also thinking about, for their users, what are the key requirements for those types of users. Also a strong emphasis on response and recovery. So it's not just prevention, but how do you increase the resilience of the overall power grid so that if there is an undesirable event, that the sites are best prepared to respond effectively and limit the overall impact to the public. And then probably one of the biggest differences between something that has regulatory force behind it and an international standard or best practice is if organizations do not comply, do not meet the standard, there are potentials for quite significant penalties, and there are actually violation severity levels that are called out within the standard that, depending on the nature of the noncompliance, depending on the time frame of the noncompliance, you may get hit with a minor violation severity level or major, depending on how big that gap is. And the fines are adjusted accordingly there. And so now with a little bit of a better background on exactly what's involved in the NERC CIP standard, we can compare it to the IEC ISA 62443 standards. And the first thing to point out is that the NERC CIP requirements are really focused here at the asset owner level, or thinking about the owner operator of the facility. It doesn't have specific requirements for, let's say a component that you buy, but there are some supply chain criteria that we'll look at. And so when we compare it to 62443, we'll start by really understanding how do the security requirements align with the security program requirements in 2-1. So if let's say we're to build a 62443 security program as an asset owner, how well would that line up with your NERC CIP requirements? Next, we'll talk a little bit about risk assessment and understanding the risk assessment process in 62443 versus impact analysis or determination in NERC CIP. And then we'll talk about the system level security requirements that are defined in 3-3. Now, one of the nice benefits and the differences between NERC CIP and IEC 62443 is 62443 specifically calls out for each of those different stakeholders what parts of the standard are applicable and what the key controls are. And we'll see that for product suppliers, right? So companies that are either building products like RTUs or protection relays, PLCs that are used in electric substations, if they comply to 62443, it will make it a lot easier to comply with some of the technical requirements in NERC CIP, and we'll take a look at that a little bit later on. Now, if we dive deeper into the parts of the standard that apply to the asset owner, we can start with 2-1. This is the overall security program. It's broken up into 8 different security program elements. So these are the high-level areas where you need to have policies and procedures in place to ensure that the right activities are happening for cybersecurity. And so the first one, organizational security, covers a lot of broad topics. It covers things like personnel security, physical security guidelines, supply chain management. And so with that, there are a lot of different specific aspects in NERC CIP that will fall under the umbrella of SPE1. SPE2 looks at your configuration management. Do you have an asset inventory in place? How do you handle any changes to the approved software list, to the configuration of devices? Network and communication security. This looks at things like remote access, how you establish zone and conduits, where you have perimeter protection, and so that does have good parallels back to NERC CIP. Component security requirements and protection of data, so a little bit more on the system hardening side of things. How do you manage confidentiality? User access control, so strong authentication and user management. Event and incident management, another key area of NERC CIP, but thinking about response plans. And then lastly, system availability and integrity requirements like backups, denial of service protection. And so 2-1 is a process standard. It's assessed based on maturity. And so really it's looking at, does the asset owner have policies and procedures defined to address these areas and address specific requirements in these areas. And 3-2 is looking at cybersecurity risk assessments. It's a method of analyzing a system under consideration or a specific, architecture, and understanding, what is the system that's going to be assessed, what are all of its external connections, and making sure that those are clearly documented. Then it leads through a multiple step process where first you look at your initial risk assessment and just trying to figure out what is the absolute worst case consequence for each device, if we assume that an attack has successfully gotten to the system, what are the potential impacts that they can cause? And so there's no likelihood consideration here. It's all focused on worst case consequence. From there, for those portions of the network that are deemed to really be mission critical for cybersecurity, the zone and conduit then looks at grouping those together, providing network segmentation or protection to significantly limit the access to those zones. Then next, for any of those areas that are above your risk tolerance, then there's the detailed risk assessment, where you really look at specific threat scenarios, different ways that attackers can get to a system, and what controls need to be in place to mitigate those threat scenarios. And then lastly, for those different zones and conduits, your cyber requirement specification is the formal listing of all of the cyber protections that are needed, information about the operating environment for that site in that zone, the threat environment that was considered. And so really kind of tying all of that information together and getting that formal document to track it. Then the last part that we'll talk about really directly applying to the asset owner is part 3-3. This is the system security requirements. It is broken down into 7 foundational areas. And really the procedural requirements in 2-1 should define how an asset owner applies the technical controls for their sites and for their systems. So for example, there's an SPE that's all about user access control. That will tie back to how they implement specific controls for identification, authentication control, and use control. So they really do work hand in hand. But 3-3 is the specific technical controls to be implemented. And those controls are based on security levels from 1 to 4. 1 being the lowest level of security needed, 4 being the highest level of security needed. And so what we can see as we start to map the standards from NERC CIP across to 2-1 and 3-3, there really is quite significant overlap between what is covered. And 2-1 from an organizational approach really touches on each of the areas in NERC CIP. For 3-3, some of them that are more let's say procedural based, for example, personnel and training, aren't specifically called out as technical security requirements. So they would be not applicable, but for each of the areas where there is a technical requirement, there's quite good overlap between 3-3 and NERC CIP. Now, that doesn't necessarily mean that every topic is covered in the same way in both standards or in the exact same level of detail or specificity, but it shows that there's very good alignment of the concepts between the standards. And if we look at kind of simplifying the different parts of NERC CIP into 3 broad categories, we could say the criticality impact assessment is really how you determine applicability of controls. It's a method of figuring out overall how much risk does that individual site or system pose to the power grid. And the higher the impact, the more controls that are going to be needed. From the 62443 side, that's kind of similar to what we're doing in 3-2, where we do our risk assessment. We try to understand what the most critical zones are or parts of a system are for our facility or for our organization. And then we focus and provide more security controls for those critical systems. For the next part, NERC CIP has some specific guidelines for minimum organizational security requirements for the security program, minimum personnel and training requirements. And again, there's a lot of similarities there between what's stated in NERC CIP and the requirements in 2-1. And then the last part could be the technical security controls or the minimum perimeter security controls, minimum data protection controls in NERC CIP, which again line up very closely with 3-3. And so if we say that conceptually the material and the concepts are aligned, the important part to understand is that there are still differences, right? And so NERC CIP is looking at everything from the perspective of the power grid. So it's looking at risk to power grid reliability, which is different than, say, looking at risk within just one organization. And so the way that you do an impact analysis is different. It really, has already baked in based on the threshold and the size of the facility, what facilities are going to have a larger impact. Whereas for 62443, it really will be driven by the organization's risk matrix and risk criteria. Next, if we think about the level of specificity, NERC CIP is written as a regulation. It is minimum requirements that must be enforced, and it tends to be very specific in exactly what it's looking for. And that, helps organizations that need to comply with it know what the regulators are going to be looking for, know what they need to do in order to comply. And so it does get very specific in those certain areas. Whereas 62443 by nature tends to be a little bit broader. It's more of a framework approach for building out that OT security program, and a little bit more of a collection of best practices that should be followed, but again, doesn't have regulatory weight behind it. And then for, again, NERC CIP, there are some very specific minimum technical security controls, whereas 3-3 has some broader security requirements that are tiered by security level, but not necessarily the same way as, if it's medium or high impact, they largely apply. If it's low impact, very few controls apply. So it is important to know, let's say, the differences between the standards when you interact with multiple ones. Now, if we think about more than just the straight, asset owner to asset owner comparison, it's also interesting to see how the capabilities needed for NERC CIP tie back to the supplier portions of 62443. And the ISA GCA put together a really great white paper on this that I definitely recommend that you check out if you're interested in learning more, that basically compares the NERC CIP requirements to ISA IEC 62443 requirements. And what they found was that the vast majority of all requirements in NERC CIP that are a technical control are specifically addressed by system capabilities within the 4-2 standard. What that means is if you as a site operator for a power station are looking to purchase a new control system and you go with a vendor that has been certified to 4-2 for the appropriate security level, when you purchase that system, it's going to have the capabilities that you need to comply with the NERC CIP regulatory requirements. Similarly, Part 13 is all about supply chain management and making sure that your suppliers have vulnerability handling programs, that you have a method in place to get notified. And all 6 of those specific requirements in NERC CIP are addressed by an organization that has implemented 4-1. So that can be a great advantage when you're picking between suppliers. Now, for those 3 specific technical capabilities that aren't explicitly addressed in 4-2, 2 of them are related to some very specific controls for remote access sessions, and having a jump server in place, making sure that you have encryption. And so although they aren't covered inherently in 4-2, if you do go through a risk-based approach, if you do have remote access defined as part of your security program, and it is specifically called out in 2-1, it's very easy to build that capability or build that requirement into your overall cybersecurity management system. And then similarly, the last one is talking about, again, how you handle or mitigate the risk of real-time communications from one control center to another. So again, it's very specific to the needs of the systems in the power sector, and it could be something that you call out as a specific scenario in your risk assessment. So there is a logical way to build that in, even if you were basing your overall program more on 62443. And so what I would propose, based on what I've seen working with organizations where They may have sites in multiple jurisdictions, or they're building sites to go, some in the US and Canada where NERC CIP is going to apply, some in Australia where SACI might apply, some in Europe where the NIS2 directive applies. Is there are going to be specific regulations for specific regions, and oftentimes having a broad framework that you can apply to all of your sites globally, and then capturing just the differences of the specific regulatory requirements tends to be the most efficient way to, or one of the most efficient ways to deploy that program. And so if you build the framework of your program on around 2-1 and your security controls around 3.3, and you call out those specific areas where NERC CIP has that more specific requirement around jump servers, or that more specific requirement around communications from one control center to another, you'll see that it's pretty easy to build it from 62443, just adding in those NERC CIP pieces, as opposed to just writing something that meets the letter of the law for NERC CIP and not really thinking about the overall approach. And then for the 3-2, although NERC CIP specifically calls out vulnerability assessments, it doesn't call out risk assessments, but they really can be a great way to identify where your electronic security perimeters are, and get a better understanding of what key controls you need to mitigate your risk. Then from a supplier selection standpoint, if you are that operator for a power sector site, if you're picking suppliers that are certified to 4-1, you know for a fact that they're going to be able to meet the supply chain security requirements. So that makes it less work for you to check that box and make sure you're getting the vulnerability notifications that you need. If you're speccing a product or a system and you know that has been certified to 4.2 or 3.3, again, you know that you're getting certain technical capabilities built in, and that's going to make it easier for you to comply with the standard. And then for those sites, again, whether it's based on region, that they have some sites that are NERC CIP must comply and some that don't, or whether it is your oil and gas site or a chemical site whose main business is process industry, but you have a power plant to support the site that's grid connected. It does really give you a good opportunity to have a consistent approach while still complying with regulatory requirements. And so now what I want to do for the last section of the webinar is just step back and kind of look at some of the key points that we can take away from NERC CIP, and think about how it applies not just to the power sector, but to other sectors as well. So the first thing is that what NERC CIP has done a really good job of is making modular requirements that allow for more flexibility, more frequent updates, right? So that split from part 2, where we talk about criticality identification, all the way down to 14 for physical security and 15 for the new internal network monitoring requirements, is by breaking up the standards by very specific technical areas. If something happened and all of a sudden the threat environment around physical security changed very quickly, and there was a new type of physical attack that the power sector was experiencing, it would be easier for NERC CIP to respond and update that specific portion of the criteria, as opposed to needing to get another revision of a 200-page standard document. And so with that, we've kind of seen that parts of the standard, some have gotten updated very frequently, others have needed fewer changes, but it has the flexibility to respond there. And that's something that a lot of standards aspire to, but it can be a challenge to really keep up with the pace of the industry. Another kind of key area is that it's been receptive to industry feedback. And it's always interesting to talk about a case where there is a regulator, and some people laugh. I was at a presentation where let's say the industries were state backed, and basically you had to comply with the state requirements, or you weren't going to operate, right? And even in that case where it was very much direct regulatory enforcement, there was still some give and take of understanding what the sites could do and trying to help them be successful. And so when you have that relationship, when there is that feedback loop, it tends to be much more successful in terms of speed of implementation and willingness to follow. And again, kind of moving those black start systems from medium to low impact level to make sure that the standards weren't unintentionally making the grid less reliable is a really good example of, being aware of what's happening in industry and taking that feedback. And I think the other kind of general benefit is it is goal-oriented, it is fit for purpose. Everything that is in NERC CIP is about improving the reliability of the power grid, and it is laser focused on that mission. And that's something that is important to take away and think about when you apply any cybersecurity standard for your organization, is what are the parts of that standard or best practice that are going to help you meet the security goals for your organization? What is critical that you do? What is nice to do that you would ideally do if you had unlimited time, but maybe doesn't need to get done first? And so really both staying goal-oriented, keeping track of why you're implementing a policy or why you're following a best practice is really an important takeaway. And what I would say is, although there are lots of different sectors of industrial systems, and they each have their own unique environment, some unique considerations, oftentimes the steps in building an effective program are much the same. It starts with building competency. So, do you understand the key requirements? Do you understand what needs to be done to secure your environment? Assessing gaps, understand where you're currently doing well, where you're falling short. Are you a extremely high risk site? Are you a low risk site? If you're falling under NERC CIP, what impact level are you? Right. So understanding where you are and where you need to be is a key first step. Then you can go about building your management system, developing your security program, and rolling it out over time. Knowing that you're not going to get everything done day one, year one, but building that plan of what does success look like. And then actually doing the training, communicating within the organization makes a big difference in terms of successful implementation. And so if you're sitting there wondering, what can you do to get started, or where is the first place to go, look at available OT cybersecurity training. There's a lot of free information that's available. There are some very good OT specific training courses. Do a gap assessment, do the exercise, and figure out what standards are applicable to you, what regulatory requirements are applicable, then see how well are you doing. And then once you know your environment, look at building the right size program. Identify the critical steps that you have to take and do those first, right? And do not let perfection be the enemy of good, right? Making progress and moving in the right direction is better than getting everything exactly right the first time. And so with that, if there are any questions that you have, don't hesitate to put them in the chat. I do want to highlight just a couple of upcoming training courses that we have available. So we've got a number of different functional safety courses that are running for the second half of the year, both online and in person. And then in addition to those, we also have a number of self-paced online courses that, again, if you are interested in learning more about OT cybersecurity, that CS 102 course is really a great option to get familiar with the 62443 standard series, get familiar with some of the key requirements for those operating sites, but a lot of other great options for safety and alarm management as well. And then additionally, for anyone in the Houston area, we will be in person on Friday, September 12th, doing a full day seminar covering functional safety, alarm management, and cyber topics. And definitely will be a great chance to have a little bit of face-to-face discussion, talk about some of the key changes we're seeing in the industry. And so for anyone in the Houston area, we're definitely excited about that and looking forward to that full day. And then lastly, if you do want to learn more, get updates about similar events and topics this in the future, don't hesitate to follow us on social media or reach out to me over email if you have any additional topics or questions that we don't get a chance to answer on today's session.